So I'm Edward Hsu, and I started my fourth wave of audio about 5 years ago. And we started last year a project, and I put together a team of people in Holland and in Monaco, and we've come up with this product after a period of 12 months, which, judging from the customer reactions, that this sound quality was possible. Through processing and through keeping control of the RF noise in the computer, then we are able to hear micro details, spatial cues, which frankly we didn't know existed. Well, so what we've done is we've addressed two issues. And for good computer playback, you have to keep control of the RF noise, and you have to have good timing. So in a computer, the RF noise, there are a lot of sources of RF noise. You have the CPU itself, you have the RAM, you have the SSD. And when we were starting with this project, our benchmark for SSD noise was to use a lithium battery. If you power a normal computer with a lithium battery for the SSD, you have a dramatic reduction in the noise. But for a commercial product, we couldn't use a lithium battery. And we spent 3 months looking for a power supply that would be as good or better than a lithium battery. And finally we found one. We ran a competition between suppliers. And then finally we had a supplier in Sweden who had a power supply for the SSD that was even better than a lithium battery. In terms of RAM, then we also realized that this is a high noise source. RAM is refreshed every clock cycle. And to the process of testing all the different kinds of RAM and then modifying the RAM, putting on much heavier heat sinks. And then we have a better sound signature, the power supply to the motherboard. And we went through several iterations. We first started the project using MOSFET regulated power supply, and we had pretty good results. But when we moved from Haswell to Skylake, and the Skylake processor, the power demands are very fast, and the MOSFET couldn't keep up. And so then said, okay, we have to scrap MOSFET supply, and we'll then experiment with choke power supply. Because we know that for Mac Mini, some companies in America had designed a choke power supply. And so we started making experiments with 1 choke, 2 chokes, 3 chokes, and then the larger chokes. And we went through about 3 iterations, and we come up with our dual choke supply. The bad news is it's very heavy, and the server weighs 31.5 kilos, and part of that are the 2 very large chokes that we have in there. For digital motherboard applications, the choke power supply is in a class by itself. So we're very much a believer that either PCM or DSD, it's very important to use the highest sampling frequency that your electronics can handle. Whenever you go to a higher frequency, then the filters that you need to use are at a higher frequency, and the slopes can be more gentle. And filters with more gentle slopes are always much less damaging to the sound than steep slopes. So whether it's PCM or it's DSD, we're always pushing for the highest frequency possible. And what's very good is that with TNA, they have a discrete 1-bit converter. And this discrete 1-bit converter runs native at DSD 512. And the performance of that, I have to say, is in terms of price performance, is a bit of a game changer. Where we see performance from DSD 512 that we can only achieve in PCM at a multiple of the price. But then you look at the component count. You have so few components in a DSD converter compared to a PCM converter. But it's always a race between sort of massively parallel PCM with DSD. And for us, it's great. Huh? The sonic frontier is being pushed by both camps, both the PCM camp and the DSD camp. But one thing we're fairly confident of is that the discrete implementations, either PCM R2R or DSD, the discrete implementations are actually better than the in-chip. And the chief designer at TNA, he said, yep, the sort of tolerances that you need, you can't achieve in an IC. You can only achieve discrete. So I think the discrete road is the correct road, either PCM or DSD. And upsampling takes advantage of those two platforms. This is the problem. As you get to a higher and higher frequency, the jitter becomes more and more significant and becomes more and more difficult to control. On the PC software processing side, what's interesting is actually timing of the computing environment is also very important. All of these software algorithms are using random number routines extensively. And these random number routines, the quality of the random numbers is also somewhat dependent on the timing of the clock on the PC. So that's one area which we paid a lot of attention to. And we did a lot of experiments with changing the motherboard clock crystal to TCXO and to OCXO. And we tried with OCXO 50 ppb and 5 ppb. And the amazing thing is we can hear the difference. We can hear the difference between TCXO, 50 ppb, OCXO, and 5 ppb OCXO. We used to think, well, we get this improvement. Is it low phase noise? Is it better power supply? Or is it the frequency stability? Well, actually, it's all three. And the fact that we can hear the difference between 5 ppb and 50 ppb shows that frequency stability is actually also very important. And one thing which we find is when we use the OCXO is we get this coherence of the sound and this purity, and it's an effect which is not huge compared to the sort of the noise reduction that we do, but it has a quality which is different from noise reduction. And it's once we heard the OCXO, we said whatever we do, it has to have an OCXO. Because of that coherence, that purity it brings to the sound. And the OCXO, because in Haswell it was at 25 megahertz, and in Skylake it's 24 megahertz. Well, you can't buy 24 megahertz OCXOs, so the OCXO is actually custom made for us. And the crystals are cut and aged in the oven for 6 weeks, and then they deliver to us. So the lead time for these OCXOs is long, but it's not an off-the-shelf component. But for us, it's a must-have. Well, what's interesting is So we built this platform to be able to do DSD 512, but what's also interesting is it actually works very well on PCM DACs at 176 and 384. And there's so many ways to skin the cat. And with PCM DACs, they're typically doing a lot of things in parallel. The Total DAC is either 6 parallel or 12 parallel. And when you do discrete implementations parallel, then you actually get very good results as well. And I have to thank Ben, because we actually hadn't spent much time with PCM DACs, because the DACs we had were PCM and DSD, and the DSD was better. We didn't spend much time on PCM only DACs, but we actually get very, very good results with PCM only DACs. And what it is with this processing software is that it's actually looking forward in the audio data stream, and it's able to detect the artifacts that were created during the original analog to digital conversion. And I think these artifacts are a big part of this digititis that people hear. Vinyl lovers, digital always sounds terrible. And that's actually caused by these digital artifacts. So in the software, you're able to find these artifacts and then eliminate them. And so this elimination of artifacts makes a big difference. And so we're getting sound quality results from these R2R PCM DACs, which is very, very good as well. No, our Sgm is USB only. Our belief is that the USB interface is the interface of the future, because it can handle the high data rates. And as we want to improve the sound quality, both on the PCM side and on the DSC side, we always have to be going to higher data rates. And with the software processing, it's just as easy to go to 384 as to 96, but you'll always get better quality at the higher data rates. And these higher data rates can only be done by USB. And for us to put in a SPDIF or AES-BAU interface, it just means more equipment, more oscillators, more noise. And so it's a bit like with Air, with their DAC, the QB9, only USB input. And it's better to do one thing very, very well than to be a jack of all trades. So we are only USB. And at the moment we are focused on delivering the best possible to people as crazy as we are. But sure, in the future, then we'll try to spread the technology at a lower price point. But at the moment, we're focused on delivering to people who are really hunting for that the best sound.